to learn, things to do.
Is it going to be due Sunday night or tonight?
So you, it will not be due tonight. I believe in naps on Friday afternoons. That's, yeah. Laptop should not be out. Thank you. All the way away, backpack. Not even on your desk. Gone. Off the desk. Marvelous, thank you. So video notes will be due Sunday night at midnight. So always just think what we're learning it the next day, so it's the night before at midnight. That's how I set all of them up. But again, you can always turn it in like the next morning, as long as it is turned in before 8:30. So before the school day starts, you are good. Okay? All right. So increasing and decreasing interval. The increasing interval is the x values that make the function, and whenever we talk about the function, we're talking about the y values, because they always say the function equals this, and when they write it, they say y equals this. So whenever they're writing it like that, Alex, you want to get your notes out? Because we're taking notes. So whenever they say the function equals something, they're saying the y equals something. So whenever they say the function, they really mean the y value. So these are the x values that make the function go up. So this is where the graph slants up to the right. The next part is a typo that I thought that I fixed, and I fixed it on some of them, and I should have fixed it on this one. Decreasing interval is still x values. It's always x values. So the decreasing interval is still the x values. It is the x values that make the function, aka the y values. These are the x values that make the y values go down. So this is where the graph slants down to the right. All right. So at this point, we have the domain that has to do with x values. We have the range that has to do with y values. And now we have increasing and decreasing with which both have to do with x values. So most of the stuff that we've talked about so far has to do with x values. Okay? So let's go back in our notes and let's actually write that down. So domain, I'm going to put this in my notes. Domain is x values, range is y values. The vertex is a point, so that's an x and a y. You could write that next to it if you want to. And then next to increasing and decreasing, I'm going to put x and x. Because that's something that students tend to start, once we have more things that we start to compare, they tend to get those values confused. Like, wait, which one's x again? Which one's y? So these are x values, okay? All right, so what I like to do is I like to use my intuition to figure this out, okay? So I'm going to draw a little stick figure right here. And that stick figure is going to help me use my common sense to do this problem, okay? If the stick figure is walking downhill, the graph is decreasing. If the stick figure is walking uphill, the graph is increasing. Does that make sense? Downhill decreasing, uphill increasing, okay? So what we have to do is we have to say where the stick figure is, and where the stick figure is the x value, okay? So right now the stick figure is at a left arrow, and a left arrow is going to be an x value of negative infinity. So the stick figure starts at an x value of negative infinity, and then he starts walking. Is he walking uphill or downhill? Downhill. So this graph starts off by decreasing. And it decreases all the way until it gets to the vertex. What is the x value of the vertex? 0. Perfect. Okay, so he decreases until he gets to an x value of 0. And then once he hits the vertex, what does he do after that? Increase. He goes uphill, which is increasing. Okay, so he starts increasing, and he increases to a right arrow. What is the x value of a right arrow? Positive infinity. Okay, so when we write the answers for the increasing interval and the decreasing interval, we write the numbers that the word is in between. So the word increase is in between 0 and infinity. So those are the answers for the increasing interval, 0 to infinity. So I'm going to write over here 0, infinity. And then the decrease is in between negative infinity and 0. So the decreasing interval, I'm going to write negative infinity, 0. And notice that I wrote my numbers smallest to biggest. I wrote my numbers from left to right. 0 to infinity, 0 is smaller. Negative infinity to 0, negative infinity is the very smallest I can think of. Does that make sense? Okay, so now I have to figure out if I should have brackets or parentheses. Okay, so infinity always gets a parenthesis. We know that, right? Now, it is tempting to put a bracket on 0 because I said, hey, if you can it with your finger and put your finger on it, you get to put a bracket. But we have to be careful because today, when we talk about increasing and decreasing intervals, we talk about, does that part of the graph slant uphill or does it slant downhill? Okay? If you look at 0, when the stick figure is at 0, is he going downhill or uphill? Neither. So we can't put a bracket there. Because if I put a bracket here, then I'm saying that when he's at 0, he's going uphill. If I put a bracket here, I'm saying that when he's at 0, he's going downhill. And when he's at 0, he's not really doing either of those things. You guys see that? He's not uphill, he's not downhill, he's in between hills. I don't know, that's nothing. Does that make sense? So we do parentheses there, not bracket. Could say, so people typically do interval notation for this, but if you prefer the set notation, you could say x greater than 0, and you could say x is less than 0, and those answers are correct. They are just not as common. So it's not wrong, it's right, but I will not be writing the answers that way. I mean, so you're right. You can write your answers that way, and it will be, but you won't be able to correct them based off my answer keys because my answer key will always be like this. Okay. All right, so let's do the other one. We're going to put our stick figure. We're going to write the x value for a left arrow. So what is the x value of a left arrow? Negative infinity. All right, so what does he do when he starts walking? Is he going uphill or downhill? Uphill, which means he is increasing, okay? He increases until he gets to the vertex. And what is the x value of the vertex? -5, okay? And then once he hits that vertex, what does he start doing? Going downhill, which means decrease, okay? And then he gets to a right arrow, and what is the x value of a right arrow? What's a positive infinity? Okay, so the word increasing is written in between the numbers negative infinity and -5. So there's your answer for increasing. Negative infinity, -5. And the word decreasing is written in between the numbers -5 and positive infinity. So we're going to write decreasing is -5, positive infinity. Infinity always gets a parenthesis. I can never put my finger on that. Then we think about the -5. Is the -5 considered an uphill? Is the -5 considered a downhill? No. So what do we do? Parenthesis. Okay. Yes?
So on both the equations, the stickman started on the left side. Is it always like
Yes.
that?
We start on the far left because we're in America, and we read from left to right. If you're in another country, would you start on the other side? So you'd still start in the left. Thank goodness we're in America, so it's not confusing. That was a joke. Good joke, Miss Wright.
All the other countries have to adapt to us.
All the other countries. So many other countries. Whew. Yeah, we start on the left side. Actually, I wonder if other countries maybe would do it right to left. We do left to right because we think that things should go left to right. I wonder if they would go right to left, if their intervals would all be right to left. But would that mess with their math, though? I wonder if their math, if they would still do their math from left to right, if their math would go from left to right, lowest to highest. Yeah. Yeah, but I wonder if their math, what their math does. You know what I'm saying? Like how it applies.
Kind of telling that the x-axis is usually left to right, the y-axis isn't always bottom to top.
Yeah, it is.
Well, not in like all left coordinates.
Tell me another coordinate system where the y-axis isn't bottom to top.
Computer graphics.
Well, that's computer. That's not the y-axis. When you're talking rectangular coordinates.
Yes, but you still have points on a computer.
Yeah, but it's not mathematical. Rectangular system. Yeah, I win. Let it be known, Miss Rice 1, Alex 0. Let's move on. All right, maximum versus minimum. I am way too triumphant about that. Let me turn off my smirk. Okay, let's move on. Maximum versus minimum. Okay, so the way that I think of maximum and minimum is I think of a maximum as like a little mountaintop. We're going to look for wee little mountaintops on the graph, and a minimum is like a little valley on the graph. Okay, so it doesn't have to be like the very highest mountaintop. It is any mountaintop. If you can see any little mountaintop on the graph, you're going to call that a maximum. Okay, if you can see any little valley on the graph, you're going to call that a minimum. All right, so it is possible for a graph to kind of go like and have like 3 little mountaintops. It's possible. Is that going to happen this unit? No, because we're talking about V-shaped graphs. So it's just going to have either one maximum or one minimum. That's going to be it, because we're starting off with the easy functions. Okay? All right, so the maximum is the location of the highest value of the function. So we're starting off this unit with kind of simple definitions because we have simple graphs. And then as we get to more complicated graphs, then we'll have more complicated definitions to work with those. Okay? So the highest value of the function, now remember the word function represents the y-coordinate, okay? So when I say the highest value of the function, I'm talking about the highest y value. Does that make sense? The highest y value. And for Math 3, we typically write those like a point, okay? The minimum is the location of the lowest value of the function, and we write it like a point, okay? Now, a lot of times at this level of math, we want the x-coordinate, we want the y-coordinate, but they can phrase these questions in different ways where they might just want the x-coordinate or just want the y-coordinate, okay? So if they say, where is the maximum located, they want the x-coordinate. If they say where, they want the x-coordinate. Where is the maximum located? What is the maximum, or yeah, where is the maximum located? Where can you find the minimum? Something like that. They want the x-coordinate. If they want to know what it is, they want the y-coordinate. What is the minimum? How low is the minimum? How high is the minimum? Something describing what it actually is, they want the y-coordinate. If they want to know where it is, they want the x-coordinate, okay? But for us, typically, if I say, tell me what the maximum is, just give me both. Tell me the x, tell me the y, okay? All right, how do your brains feel so far? Good? Okay. Draw an example of an absolute value function with a maximum of 3, -2. Okay, so let's start with that point 3, -2. And if we want that to be the maximum, what should we do from there? Yeah, that has to be the top of the V. The V has to go down from there. So I'm just going to make this be like go down 1 over 1, down 1 over 1, because that's the easiest to draw. There we go. So there is an absolute value graph with a maximum of 3, -2. Draw an example of an absolute value graph with a minimum of your choosing. So what do you have to draw if you want a minimum of your choosing? What does it have to look like? Just a regular V. Just got to be a V that goes up. A regular V. I decided to make mine with a stretch of 2. I know, so fancy. Okay, that's all the notes we're going to take for today. So let me look. Well, that's not all the notes. That's all the notes we're going to do on this part. Let me look at Canvas real quick. Okay, so for that packet, do 22 through 27. So just a few problems. It has some that are, I believe, that have the vertex, maybe, and then some that have increasing, decreasing, and max min. So just a few little problems. Okay, so I'm going to go ahead and hand out a worksheet that has to do with your notes from last night so that we can practice that. Are there some problems on here that look intimidating? So the first couple probably feel comfortable, but then as we keep going, are there some that maybe have enough going on in them that they look intimidating? Okay, so where does it start getting intimidating? 7? Okay, so let's do number 8. So 7 is your homework because it's an odd, but number 8 is not. So I'll do number 8 as a sample. So when I talked about in the video is that you can always use "Please excuse my dear Aunt Sally" backwards to help you solve an equation. All right. So the first thing that we're going to do is look to see if there's anything we could add or subtract outside of the parentheses, to see if there's anything we could add or subtract over to the other side to start isolating the variable. So if you look at this problem, is there anything that could be added or subtracted? The -10, can this be added or subtracted? You'd have to, okay, so we can't do any adding or subtracting. What about multiplying or dividing? Yes. Okay, so we're going to divide by -10. All right, and then from there, we don't have the e, we don't have any exponents to take care of. Now we can get inside the parentheses, which in this case happens to be our absolute value. That's our grouping symbols. So now we have a positive distance, which is good. That tells us this is not a no solution problem. So that's important. Well, it's not good if you don't want to have to do the problem, but okay. So what should I write for my two situations? I have the negative version. And then I have the positive version. Okay, and then at this point, I just go up and I start the process again. All right, which version do you guys want to do first? The negative version? Okay. So the negative version, there's not something that we could add or subtract. We could divide by the -1. Okay. So you can divide that -1 to kind of get rid of it, or you can distribute it to the parentheses. Either one of those things would work. And now we can kind of solve them both the same way because they look the same. So what should we do now? Add 1. So 10n equals -8. 10n equals 10. Okay. And then what? Divide by 10. So what does n equal? And then the other n equals 1. And then I wanted to do number 16 also. So let's go ahead and flip to number 16.
Let's see, what was the answer for number 8?
-4/5 and +1. Okay. All right, is there anything you could add or subtract to the other side? Yeah, the 3 can be added. All right, is there anything that could be multiplied or divided to the other side? 7. Then what do we get? -13. And when we see an absolute value equals a -13, that's telling us a distance is -13. And so what is our conclusion? No solution because a distance cannot be negative. Okay. So really easy to miss that. In fact, you could go on solving that problem and get 2 answers. Yeah, really easy to miss that, okay? So you just got to be careful. Yeah. It was -9 after we kept going. The thing that was important is that it was +9 right there. Yep. Okay. So what I would recommend is don't start at number 1 because number 1's easy. You can do that at home. Start at like 7 or 9. Start around there and do a couple of those and just make sure that you can do some of these multi-step problems. And then you can save the easier ones for when you go home, okay? So we're starting off doing some of these solving equations right now, and then we're gonna move on to doing some inequalities. So I'm gonna give you guys like 15 minutes probably, and then we're gonna practice solving absolute value inequalities, okay?
So front side odds are in class and the back side odds are...
So all the odds are what you're working on. You'll see how many you get. Okay. Yes.
When is it due? Monday?
Yes. So we know from last night's notes that the absolute value of x is equals 0, that what that literally means is the distance. I love it when I do that.
Wait, really?
Wonderful.
Nobody said anything?
We had a fun time just watching it. It was a flood in the chat.
Oh no. Okay, the distance from x to 0, or yeah, the distance from, hold on, this right here, shouldn't say equals anything. This right here means the distance from x to 0, and then you could say equals whatever. So if I write absolute value of x equals 3, then I am saying the distance from x to 0 is 3. It's exactly 3. That's what I'm saying. That's what that means. So if I were to draw a number line, then here is 0, and I would go 1, 2, 3, so this is one solution, and then I would go 1, 2, 3, and this is the second solution. And so my two solutions are positive 3 and negative 3. So that's what an equation means. So if I switch that and I start doing inequalities and I say the absolute value of x is less than 5, what I'm saying is the distance from x to 0 is less than 5. So how would I draw that? Uh-huh. Yeah. So how many answers would I have? Infinitely many answers. So I'd have 0. And then I'd say 1, 2, 3, 4, 5. But I would not include the 5. And all of this would be considered a solution, right? Infinitely many solutions in here. Because all these distances would be less than 5, right? The distance from 0, from x to 0, is less than 5. And it would also go the other way. 1, 2, 3, 4, 5. All these distances would be less than 5. So infinitely many answers, because that's what typically happens with inequalities. So I can't include the 5s, but I'd have everything in between. And if I was to write this answer, I would say x is in between negative 5 and 5. So when I'm doing an inequality problem, if I have my absolute value sign isolated and the number over here, and this is where I get my color out. I'm going to use marker actually. Make it easy for you guys to read. If I have my absolute value sign isolated and then my number and a less than sign, then I'm going to remember that it is less than. And it's going to be between one number and another number. I'm going to remember that it makes a sandwich, less than. It's between one number and another number. Does that make sense? Less than. So gimmicky. So great. What a wonderful math teacher you are, Miss Rice. Why, thank you, Miss Rice. I appreciate the compliment. All right, next problem. Absolute value of x is greater than or equal to 4. Okay, so let's think about what this means. The distance from x to 0 is greater than or equal to, I always write that, equal to 4. The distance from x to 0 is greater than or equal to 4. Okay, so let's think about what our number line should look like. There's 0. What should I draw?
Lines with arrows.
Yeah. So 1, 2, 3, 4. So there's the 4. So it can be equal to 4, or it's got to be greater than 4. So it's got to go this way. And then 1, 2, 3, 4 equal to 4, or the distance can be more than that. Okay. So if the inequality is solved for, or if the absolute value sign is alone, and the number's over here, and we end up with a greater than sign, I'm going to say greater, then your inequality goes one direction or the other. One direction or the other. X is less than or equal to -4, or x is greater than or equal to 4. So if you have a less than symbol, it's between one number and the other. If you have a greater, it's less than or greater than. Does that make sense? So when you solve the problem, your numeric answers would be the same no matter what the inequality symbol is. The numeric answers are not going to change. So if you mix up how these symbols work, the only thing you're going to get is you're either going to make a sandwich when you should have had the answers going the opposite directions, or you're going to have your answers going opposite directions when you should have made a sandwich. Okay? You're not likely to have your number answers be wrong. Does that make sense? Okay? So when I have students do these problems, they typically get their numbers right. It's typically the way the answers should be written that they end up making the mistake in. Okay? All right, let's try a couple of these. So the solving is going to be the same. The steps are going to be the same as the equations. We're still going to do order of operations backwards. It's just that the final step of how we write our answers is the part that's going to be a little bit different. The part where we figure out if it's greater or less than. Okay? All right, so here is example 1. We've got -4 times the absolute value of 3n plus 6 is less than or equal to -24. And it is still possible for us to have that negative distance and get an answer of no solution. So we are still going to be looking out for that because we could have those no solution answers, okay? Now, I do not look at the problem in the beginning to see if it's greater or less than. I have to get the absolute value sign completely alone first, okay? So the fact that I have the -4 in the front tells me I should not even be caring what the inequality symbol is yet, okay? Now remember, there are some reasons that we would flip an inequality symbol. Do you guys remember when we have to flip it? Multiply or divide by a negative, okay? So just keep that in mind, and that will help us do the problems correctly. Okay, So if we start this problem, is there something we could add or subtract to the other side to start isolating the n? Nope. Is there something that we could multiply or divide? Yes. It is the -4. And when we divide the -4, what do we have to do to our inequality sign? We have to flip it. Right? So at this point, my inequality sign is ready to be looked at because my absolute value symbol is by itself. So what direction is this going? What does it tell me about the problem? It's a greater. This is great or. It's a greater problem. So here's how I'm going to write it. I'm going to say 3n plus 6 is less than or equal to the negative version, or 3n plus 6 is greater than or equal to the positive version. All right, so it said greater, and so I'm giving it the option where it goes the two opposite directions, left, right, negative version, positive version, splitting it myself. Does that make sense? Okay. So greater, well, there is my split right there. Okay, so now what should I do? Minus the 6. Okay. 3n is less than or equal to -6 minus 6, -12. 3n is greater than or equal to 0, okay? And then what should I do? Divide by 3. Alex, you taking notes? Not in your brain, on paper? So n is less than or equal to -4, okay, or n is greater than or equal to 0. Perfect. There we go. Yeah, if you wanted to, you could set them up as, if you wanted to do the distribute the negative way so you're consistent with the equations, then you would say -3n plus 6 is greater than or equal to +6. You'd start it off like that, and then you could do the problem. Okay. All right, example 2. All right, this one says absolute value of 6 plus 7x plus 2 is less than 52. So first, is there something we can add or subtract over to the other side? Yes, we can subtract the 2. All right. And at this point, we have the absolute value symbol is all by itself. So, 50, not 52. Thank you. And this is a less than problem. And so that means we write it as a sandwich. So we're going to put 6 plus 7x in the middle. And we're going to put negative 50 on the left side and positive 50 on the right side. So we're making it a sandwich. So here are, we still have two options, but they're written as a sandwich. Does that make sense? Sandwich. All right. So we want to get the x in the middle by itself. Should we get rid of the 6 first or get rid of the 7 first? The 6. What do we do with the 6? Subtract it. So this is kind of a weird problem because you don't have an equation with 2 sides, you have an inequality with 3 sides. So subtract the 6 from all 3 sides. Oh, 54. 44. My mental math today. I was like, I don't need a calculator, I'm fine. I'm a math teacher. Nope. All right, now what should I do? Divided by 7 from all 3 sides. Okay, 44/7 does not go unevenly, but does it reduce? No. 7 is a prime number. So 44/7 is there to stay and just be ugly. 56/7. -8. Beautiful. Look at that lovely math sandwich. So fun. Yeah, so what I say with fractions is unless the decimal is nice, meaning it doesn't need to be rounded, unless it's nice, leave it as a fraction. Because accurate answers, like exact answers, are always better than rounded. So unless they tell you to round it, leave it as a fraction. All right. Make sense? Okay. So if you guys are comfortable, the plan is to, instead of do a worksheet, have you guys work in groups and do problems on notebook paper and do problems one at a time where you check the answer with me before you get a new problem. So you'll do a problem, write it down on a piece of notebook paper, check the answer with me, and then when I'm convinced that you're comfortable with that problem, then your group would get a new problem to work on. Does that make sense? You would work on it together so that the group has to kind of understand the problem before you move on. Does that make sense? Okay. So go ahead and get out a sheet of paper. Your name should be on it. So when you turn in your work on Monday, you would be turning in 2 things. You would be turning in the worksheet that has the equations on it, and then you'll be turning in this sheet of notebook paper that's going to have the inequalities on it, okay? You will be doing 8 problems. That's the goal, is to do 8 problems. So you're going to put number 1 next to the first one, and then number 2 next to the second one. We'll see how many we get done, okay? So put your name on it. Everybody's going to show the work on their individual notebook paper. So everyone has their own name on it, their own work on it, everything written down in your own handwriting. You're going to get the problem on a little slip of paper. When your group is done with the problem and you're pretty convinced you got it right, you're going to take the answer and you're going to write it on the slip of paper. You're going to have one representative from the group bring the slip of paper to me in the back. I'll be back there. If you got the answer, I will trade the slip for a new. Sound good? simple problems, and then once it seems like you guys are comfortable, I'll start giving you problems with more steps in them, okay? We just want to make sure that these make sense.